Okay, so we'll be using the same equipment as last time. However, Mr. Dickey ran this lab this morning, and he used these like cheapo tracks we got as demos. They were like essentially free. They also work really good, so we don't have to have the gigantic groups we had for the first lab, right? We have plenty of tracks now, so we can have much smaller groups, okay? Because we've got 8 carts, so he said that this worked really well, okay? And so everybody has, or not everybody, we can have groups of like 3 or 4 instead of 8, okay, like we had last time. All right, so purpose of this lab, guys, or the problem that we're investigating, what type of motion is experienced by a cart rolling down an incline? Spoiler alert, it might be in the title. Yeah, okay, so just putting it out there, it could be there. You might find it there. Okay, so for our design, here's how the lab will work. You're only going to do one run. Okay, so one run and one run only. And you're just going to have a very slight incline to the ramp. Okay? Mr. Dickey said that this morning, these new carts work so well that they only required the cart's box as the height of the ramp in order to make this work and get good data. Right? Now, if we're watching our app, okay, as the cart rolls down the ramp, what shape should we see for the position versus time graph or the velocity versus time graph?
Triangle.
For which graph?
Velocity versus time.
Right. Okay. We should see on the velocity versus time graph, and this might be useful in your hypothesis. Okay. We should see if it's showing us the velocity versus time graph. That, because that is what on a velocity versus time graph an accelerating object would look like, because the velocity is getting higher. Okay? On the position versus time graph, what should it look like? It should be a curve, right? Okay? It should look like this. So once you've got that as your data, you're done collecting your data. Okay? Like, collecting the data today should take no time at all. You realistically should be able to get the entire lab report done in class, right? If you stay focused and you don't fool around too much. Okay? You should be able to get it virtually all done, right? Because you're only got one run to work with, two graphs to build, okay? But only one set of data to do that with, so it should go pretty fast. Okay, so for the design, all we're doing is running the cart down the ramp one time. Okay? We are measuring during that trial the position of the cart and the velocity of the cart. Those are the two things we are measuring, and of course, time. Okay? Whenever time is involved, time is which variable? It's the manipulated variable. Okay? You're welcome. Right? So whenever time is involved, time is the manipulated variable. Right? We're determining the length of the experiment in terms of time. That will affect everything else. Okay? A very common mistake on this lab is to say that the manipulated variable is the incline of the ramp. Why is that wrong? Besides, I just told you it was time.
You just said that it has to be the height of the box.
I said it has to be the height of the box, and I never said we would try any other heights. Therefore, I'm not manipulating the height of the ramp. We're only doing one try. Okay? So, manipulated variable is time. We're measuring two other things. Is it possible to have more than one responding variable? Yes, it is. It might be. Here it's far. Okay? For our controlled variables, okay, in this lab, we want the acceleration of the cart to be constant. If it's constant, then it's not changing. Agreed? And there's a certain kind of variable that's not changing. And the reason acceleration's not changing is because of some of the things at work here in this system. Especially the force that might be helping to pull the cart down the ramp. Inasmuch as we have no ability to change that force at all, and it should remain constant throughout the lab. If it doesn't, we're A, in really big trouble, and B, going to get really wacky now. Okay? All right. For our hypothesis. What 3 words go in a hypothesis? If, and, then. Okay. The if part of our hypothesis, right, should talk about what acceleration is. Okay? That's because that's what we're doing here. The problem we're investing in is what kind of motion does it experience? It's accelerated, so what is accelerated motion? Okay? You might have got a definition of that the other day. Not yesterday, but the day before. Okay? You might have got a definition of that, so it's probably in your notes somewhere. Right? The and part is going to describe the experiment. That's pretty simple. The cart is allowed to roll down a ramp. Something like that, but you probably want to add more than that. Okay? But describe the experiment, what's going on and what's being recorded. Okay? In the then parts, okay, I'm going to want 2 things. Okay? I'm going to want you to tell me how you'll calculate acceleration. From the velocity versus time graph. We had a little issue with that on the last lap. So I'm going to reiterate that I want to know how you're going to calculate acceleration from this graph, and only from this graph. Okay? The other thing I'm going to want is a prediction of the shapes of the 2 graphs. Oh, we might have already spoiled that. Okay? Is your hypothesis going to be kind of long?
Yes.
Your English teacher might tell you it was a run-on sentence. They may be right, but I don't care. Okay? It's a hypothesis. It's supposed to be long. Okay? It might be a run-on sentence, but it's going to say what we need it to say. Okay, so like we said here, for the procedure, okay, the apparatus is going to get set up like this, except not like this. Please do not set it up on top of the desk. Yeah, the cart will fall off and be destroyed, and then I'll be very angry. So we just set it up on the floor. We don't need a really big incline. In fact, we don't want a really big incline because it's harmful to the carts to come crashing down at high speed off of that. Right? So keep it low. Really, all you need is 1 box. Okay? Just the box for the carts will be sufficient to get you good accelerated motion data. Okay. So run that one trial, and then we'll look at the data. Okay, we'll get our data together, and we're going to build 2 graphs. Okay, so we're going to be plotting a graph of position versus time, and a graph of instantaneous velocity versus time. So those are the 2 things you need to tell the app to record. Right? Everything else you can get rid of. You don't need to record acceleration. You don't need to record anything except the position and the velocity of the cart.
So are we pushing the cart off?
No, you're just going to put it on the ramp and let it go. Good question. Okay, no, you're not pushing the cart like we did last time. Place it on the top of the ramp. Okay, 3, 2, 1, let it go. Okay, just let it roll down the ramp. That's all we're looking for. Okay, a couple of things it says on here. Make sure that the wheels on the cart are freewheeling, so just make sure that they're clear and spinning freely. Okay, make sure that the ramp is as clean as you can check it for. Grab a piece of paper towel there and just wipe it off. Okay, and plot those 2 graphs like we said. So for the analysis, okay, using your graphs, identify the type of motion that occurred in this lab. So what I'm looking for there, okay, for the first part of this question, okay, is why did the shapes say acceleration was going on? Okay, so that's what I'm looking for that part of that question. Okay, so you say to me, the position versus time graph had this shape, and this means the object was accelerating because it says the object did this, this, and this. Okay, and then I want you to show calculations to prove and explain your reasoning. Basically, that's this part. Okay, I want you to calculate the acceleration from the position versus time graph. Okay. So that's going to be the second part of that. Show me that calculation. Okay, second question. with your graphs, there are two ways to find the displacement of the object. So you can find the displacement of the object from the position versus time graph. Show me that calculation and the number. And show me the calculation of that from the velocity versus time graph. Okay, so show me the calculation and the number, and then you need to explain any differences, because theoretically, those two numbers should be, it should be the same. Okay, now, you're going to be close. You're not going to be exactly the same, but okay, you're going to be pretty close. If you're way off, okay, like you're off by more than 15 centimeters over the length of that ramp, you really did something wrong somewhere. Okay, but realistically, you should be very close. Right? The key to this is that you need to use all of your you have to use an equal amount of time data from both graphs. Okay, so when you're calculating the displacement, if you're using a position time graph and you're going to time like 1.1 seconds, you got to go to 1.1 seconds using the velocity time graph as well. If you use a different amount of time, it's not a fair comparison.
What do you want the same number?
I don't know, 1 decimal place.
Or,
Okay, or let's say, because it'll be in meters, let's say 2 decimal points. So that'll be the nearest centimeter. All right, does everyone follow me on that? Okay, and you might have to refer back if you don't remember, okay, how we calculate displacements. Okay, it may even be possible using your graph, okay, to use a formula that we learned yesterday. Because there is a formula we learned yesterday that would use data from our graph, in fact, from the graphing equation from our graph, in order to help us do this. Right? But that's one of the things I want you guys to figure out, as opposed to what I'm going to tell you. Okay, you guys can figure it out. All right, conclusion, same as always. Okay, restate your hypothesis, explain using your data and analysis why it's accepted or rejected. So basically, did you see accelerated motion? How did you know? Talk about your graphs. Okay, things like that. Okay, sources of error, identify 2, and give me ways to fix them. Okay, you don't have to do the class discussion. We'll talk about that when I hand back the lab and go over it with you. Okay, let's have you guys collect data, and then I'll quickly walk through the building of the graphs again, just in case anyone's forgotten how that works. Okay.
Are there 3 control variables again?
Yes, 3 controlled variables, okay? But there are 2 responding variables for each. Okay, any other questions there, guys? Okay. I'm going to put the instructions for those carts back up on the board as well. All right, so first thing you need to do with this data is you need to get rid of the stuff we don't want. That is row number 1. We do not want all of those names there. Okay, run 1. We only have 1 run, so we don't need to say that. Okay, so that's gone. I also don't need the date and time.
1-1.
So I'm going to delete that. But guys, I need you listening. Okay, I also don't need the acceleration, so I'm going to get rid of that as well. Okay, now I have the data that I want. I need to build 2 graphs. One's a position versus time graph, one's a velocity versus time graph. So I am going to simply highlight the data, okay, and I'm going to put in a chart. I'm going to make it a scatter plot, same as last time. Okay, there's my points. Right? They curve slightly, which is perfect. That's what they're supposed to do. Okay, and then I'm just going to go to customize because it already labeled everything nicely for me. I don't have to change anything there, okay, except maybe the title, but I'll do that in customize. Actually, I'm not even going to change that. Just to show you guys here. All right, so in series, okay, we want to have a trend line. So we click on that. But this time, I don't want it to be linear. I want it to be exponential, because I'm supposed to have a curve here. Okay, it doesn't really fit all that well. Okay, but it should be a little more curved. Okay, and that's fine. I don't want that. Okay. Now, part of the reason it did that is because I have this point over here that's not fitting. Okay, see how it's not on the curve? So I'm going to take that point out. I'm just going to move this over, and I'm going to remove this point here. Okay, switch it off. I'm also going to get rid of that. I'm not going to go to 20 seconds. Okay. Alright, the rest of it seems to fit pretty well, so we'll go with it. Now, there's my position versus time graph. Okay, that's my last one. Now, if you look on here, guys, if you highlight or put your cursor over any of the points, it gives you their values. Spoiler alert, you're going to need that number when you're answering question number 2. Okay, from the positions, remember you're supposed to calculate the displacement from the position versus time graph. You're going to need this number right here to do that, as it represents the final position of the cart. Okay, now the other thing I have to do is I need to make a velocity versus time graph for this. Right, so I'm going to highlight those 2 columns. Okay, so these are the 2 I want to highlight now. I'm going to insert a chart of those. Okay, and obviously that kind of falls off, so I need to take out a few of the times here. Okay, so I can see here that it stops accelerating. Okay, it accelerates to about 0.5, and then after that it's the stopping phase. So I'm going to get rid of all of these points here. Okay, so we get a nice, and I'm going to put in 0 here. There really should be a 0 there. Okay, and then I'm going to change the type of graph.
Why are you making a graph too?
I want it to be a scatter plot. Okay, so now I've got my line here that I want to have for that graph. Okay, guys, I need you listening and not talking. The microphone picks you up, and you're not going to be able to use this because all you're going to be able to hear is you visiting instead of me telling you how to do this. Easton, just wait. I will get to you in a minute. Okay, so what we need to do here, guys, is still continue to edit this chart. So I've got a scatter chart now. Okay, it's already got all the labels on it the way I want. I'm going to go to series, same as before. I want a trend line. Put a linear one on. Okay, I want to use the equation for the label. So here where it says label, use the equation. Okay, and now that graph is set up the way I need it as well. Okay, here's y equals mx plus b for that line. That's going to be useful, okay, for both questions in the analysis. And you'll need the numbers from there for that. Right? So that's how you build those 2 graphs. Once you have them done, okay, this is the thing people didn't do the last time. Right? So you have your lab report open, and here in the data it says insert data charts here, insert graphs here. So remember to insert both, because a number of you lost marks on the last lab, okay, because you didn't do that. Okay, so we're just going to copy that data over. I'm going to put it in here, and I'm going to link it, okay, and then I'm going to put in my graphs. Okay, same deal. Okay, copy the charts, go back to the lab reports. Paste it in there. Okay, and then same thing for the other ones. Okay, go back and put them both in there. Right, then you got your chart as well as your graphs in where you need them to be. Everybody follow me on that. Okay, should be able to do the rest of it and get the majority of it done, as you still have over 50 minutes. Sorry, you have over 40 minutes to do this. Easton, question?